If you ask an astrophysicist what shape the universe is, they'll tell you something that sounds absolutely ridiculous. The universe is flat. Now, they don't mean it looks like a cosmic pancake. You can look up, down, left, and right, and clearly see the universe has 3 spatial dimensions. So, what exactly do cosmologists mean when they say the universe is flat? The answer lies in the ultimate cosmic tug-of-war, the oldest light in existence, and a set of rules you probably learned in middle school geometry. To understand a flat universe, we have to talk about geometry, specifically Euclidean geometry. On a flat piece of paper, if you draw a triangle, the internal angles will always add up to exactly 180 degrees. And if you draw 2 parallel lines, they will go on forever without ever touching. But if you draw that same triangle on the surface of a sphere, it bulges outward. The angles add up to more than 180 degrees. And those parallel lines, they eventually intersect. This is called positive curvature, or a closed geometry. Alternatively, if you draw it on a saddle shape, the angles add up to less than 180 degrees, and parallel lines diverge, moving further apart. This is negative curvature, or an open geometry. For decades, physicists wondered which of these 3 shapes described the very fabric of our spacetime. If you shot 2 laser beams perfectly parallel across billions of light years, would they eventually cross? Would they spread apart? Or would they stay perfectly parallel forever? To figure out our universe's shape, we have to look at what's inside it. Since the Big Bang, the universe has been expanding, but there is a counterforce trying to pull it all back together: gravity. Specifically, the gravity of all the matter and energy in the universe. This creates a delicate balance, defined by something called the critical density, represented by the Greek letter ρ. Critical density is the exact amount of mass and energy required to perfectly balance the universe's outward expansion. We express the actual density of our universe compared to this critical density using the parameter omega. If omega is greater than 1, gravity wins, curving the universe into a sphere. If it's less than 1, expansion warps everything into a saddle. But if omega equals exactly 1, they perfectly balance, making the universe perfectly flat. But how could we possibly measure the density of the entire universe? Enter the cosmic microwave background, or CMB. This is the afterglow of the Big Bang itself. It's the oldest light in the universe, frozen in time from when the cosmos was just 380,000 years old. Those tiny red and blue speckles, they are microscopic temperature fluctuations. Physicists know exactly how large these temperature spots actually were back then. Because we know their true physical size, and we know how far away they are, we can use them as a cosmic measuring stick. It's the ultimate triangle. If the universe was spherical, closed, the light rays traveling from those spots to our telescopes would bend inward, making the spots look larger than they really are. If the universe was a saddle, open, the rays would spread out, making the spots look smaller. But when satellites like WEMAP and Planck measured the CMB, the spots were exactly the size they should be if light traveled in a perfectly straight line. The angles of our cosmic triangle added up to exactly 180 degrees. The math was undeniable. Omega equals 1, with a margin of error of less than 0.4%. The universe is undeniably geometrically flat. But this incredible discovery comes with a sobering realization about our ultimate fate. Because the universe is flat, it means gravity isn't strong enough to pull everything back together for a cosmic reboot. And it means the universe won't violently tear itself apart. Instead, a flat universe is destined to expand forever. Trillions of years from now, the stars will burn out, the galaxies will drift apart, and the cosmos will fade into a cold, dark, endless flat void. A bit gloomy? Maybe. But for now, we get to exist in this perfectly balanced, perfectly flat sliver of spacetime, capable of looking up and figuring out the shape of reality itself. Thanks for watching, and stay curious.